and welcome to the next installment of Ortho Real podcast. Today we are talking about custom implants for knee and hip surgery. It's a topic of interest to me as I've had a strong interest in this technology over the last several years. I have used these types of implants many times. In the interest of full disclosure for any biases, I, as noted, am a user of this system. The company that we're talking about today is Conformis, that manufactures custom implants and the systems associated with them. I have done some limited teaching for this company in labs for other surgeons and in some context of that nature. I do not have any royalties associated with this implant or anything of that nature, but have worked with them in the past, so notable in terms of keeping this unbiased and keeping this real, if we're on the Ortho Real podcast. Joining us today from Conformis are John Slamin and Farzin Khaghani. John is an engineer and now Chief Technology Officer at Conformis. He has been involved in the design of orthopedic implants for well over 30 years. Farzin, also with a strong engineering background, but is involved in the sales and marketing for this company. So we're excited to have these two gentlemen and talk about custom implants and what they're doing and why and what the future holds for this technology. So for those of you that are interested or potentially have any interest in learning about custom implants, thanks for stopping in and listening to this podcast. Joining us today are John Slamin and Farzin Khaghani. Gentlemen, welcome.
Good morning and welcome. Thank you.
Good morning. Thanks, man. Thanks for having us.
Appreciate having you guys here, and I hopefully have done enough in the way of introduction. But both of you have been with Conformis for quite some time. Both of you, Farzin, you're on the sales side now. John is the Chief Technology Officer. Both of you, though, coming to this with engineering backgrounds. Can one or both of you tell us the story about Conformis and about custom implants and what's the origin of this thing?
Yeah, Conformis was founded in 2004 by a radiologist. His name is Philip Lang. And although not a founder, the first employee's name was Daniel Steinus, who was actually an MD, but was much more interested in software. And so he went off after his MD and studied software and developed the foundation for what all of Conformis software is today. They started, the first implant that they developed and introduced to the market was a interpositional device made out of cobalt chrome, and it was MRI based. And we developed and marketed that product up until about 2010 or so. Like most interpositional devices, it was a bit of a hit or miss in terms of patient satisfaction and clinical outcome. But shortly thereafter, that product went to market. We started developing partial implants, which a unicompartmental and then a bicompartmental, which were the first truly patient-matched implant systems in the world in terms of a system. Custom implants had been made for many years, going back to probably the late 1960s. But those were typically used for severe deformity and severe revision situations, where these were patient-matched primary orthopedic devices, which is distinctly different, which had been done in the past. And then the partial knee implants, we evolved into developing a total knee, which we started working on in 2009, and that's become the backbone of the company now for 10 years. We introduced the iTotal cruciate retaining to the market in 2011, and we introduced to the market in 2015 the iTotal posterior stabilized implant system. Farzin, I'm sure you could fill a lot of gaps in there.
Sure, that's a great synopsis. I would actually probably go back an additional 4 years before 2004. Philip Lang and Daniel Steinus, there was a company called Imaging Therapeutics that was a software company, looked at x-rays in bulk and picked out patients, osteoporotic patients. So I think that was really the genesis of some of the core software that ended up translating and becoming and evolving into Conformis. Some people that have been familiar with the company over the years always ask, why would you start with an interpositional spacer, go to a uni, a bicompartmental, and then a total? Just given the market size, the most logical step would be to start with a total knee implant, and I think that has a lot to do with the genesis of the company and the history of it. Initially, the company was looking at addressing specific point defects there, where you could take metal and replace worn cartilage in specific areas, and that kind of morphed and became an interpositional spacer, and then eventually a unicompartmental and bicompartmental. So we actually went down the path of knee replacements a little bit backwards, starting out with more conservative implants, and then eventually to a total knee system.
But that is true, Farzin. But I also believe that although it was probably backwards to what any other orthopedic company would do, we cut our teeth on the partial knees, and we learned a lot about how to apply imaging technologies and refining our software in extracting the shapes and designing patient-matched orthopedic implants. I think that if we had started with the total, we would have made a lot of mistakes on a total, and we may not even have survived today. Whereas we learned our way up to the total knee. And by the time we got the total in 2011, it was a pretty solid product. And not to say that it didn't evolve substantially, and it continues to evolve today based on feedback from customers and things we see. But I'm actually happy we did it the way we did it.
Yeah, no, that's very true. It's well said. I don't think any of it would have been possible without the confluence of additive manufacturing technology, the software technology to be able to actually handle the workload, the tasks of designing a custom implant, as well as advances on the orthopedic side to make all of this possible. But I agree with you. I think it definitely served the company well. When an off-the-shelf implant is effectively designed to average values. So engineers will gather a bunch of anthropomorphic data and try to make a limited number of sizes fit as many patients as possible. And that's traditionally has been the approach with most orthopedic companies. But taking that each individual patient has a unique problem where you're designing a unique solution for is an extremely complicated process. And I agree with you, John. I think starting out with partial knees definitely serves us well and bake the technology for us to be able to really create something special on the total knee side.
Right.
Okay, so y'all have given me a ton of places to jump off here already and talk about with interpositional arthroplasty and maybe coming from the background of the unispacer and some implants like that, where for a patient or somebody who's not in industry, are we talking about basically a spacer device, a little piece of metal or something else that sort of pushes into the joint and holds it open where there was a defect or missing cartilage?
The brand was called iForma, the interpositional device that Conformis had. And essentially what it was, yes, it was a metal, like a small metal plate, but it was not, it was contoured to the patient's natural soft tissue geometry. This was an MRI-based device. And so it was essentially a replacement for a failed meniscus. The meniscus had to be removed in order to use this device, the iForma. and then it would be literally pressed into the knee, taking up the space that the meniscus had previously taken up. It was metal cobalt chrome, and when it worked well, it worked very well. But it was difficult to predict what patients would do well with it and what patients would not do well with it.
So the idea to start here and to start working on some of this, were these guys, Dr. Lang and the other originators, as you spoke about, John, there was some market or some small niche of custom implants going back for a long time. Were they sort of riffing on the available technology here of, okay, now we've got better imaging, we've got better software, we're going to let this technology see what it can do with these orthopedic products, and so they decided to grow it in that direction, or what was the thought here?
Yeah, well, the founders, Lang and Steinitz, I mean, they really thought out of the box. I mean, having one of them being an interventional radiologist and the other one being a software developer, and Philip Lang had actually, when he was doing his postdoc, had actually worked or supported some research. Now we're talking in the mid to late 90s now, of a custom orthopedic company that was based in Sacramento, and the name of that company is escaping me right now. And they would build, Lang would support them in some research using CT scans, but they were manufacturing custom implants to repair complex revisions where the previous implant had failed and there was a lot of bone erosion or possibly fractured, femurs and fractured tibias and things like that. And they were making truly customized implants, one-offs. And they so then Lang, I guess, took that basic idea, working with Steinitz in the software field, saying, if we could extract patient matched data information from their bones and then build an implant that was shaped, not just size, which is a real fundamental difference, but shaped to the patient's natural geometry, maybe we could get better outcomes than the off-the-shelf implants, which, as Farzin said, are very generic in nature, very engineered kind of shapes that sometimes you get the right size, but rarely you get the right shape with an off-the-shelf implant. So that was their fundamental premise. And they started it with the iForma interpositional, and then it evolved into the iUni, and then the iDuo, which is the bicompartmental device. And their idea, their premise, that probably dates back to the late 1990s, turns out to be true. That if you design an implant that is based on the patient's natural geometry, not their size, but their actual bone shape, then you will get an implant that has got better outcomes, better patient satisfaction, and equal survivorship to the more traditional methods. Keeping in mind that we're providing customized shapes to the patient's bone, but all of the materials that we use, all of the fixation methods to the bone that we use have been proven over time. So we didn't want to abandon anything that has proven long-term to work well in joint reconstruction procedures. We only wanted to change the shape of the way the implant articulates, the way it moves, based on the patient's natural geometry. And if you look at all of our published literature now, peer-reviewed published literature on this, in virtually any criteria that you would want to establish, this implant system works better than any other total knee system on the market today.
I think what John has just said is so important, and I want to emphasize a couple of points. We from the very beginning of Conformis, we wanted to stay true to what orthopedics has taught us. We wanted to make sure we stayed with known material, with known fixation, with the idea of a mechanical alignment, which I think is definitely worth getting into more, because we actually positioned the final implants in the kinematic alignment, but leave the benefits of a mechanical alignment. But the benefits of the system, we wanted to make sure we were reaping the advantages of creating a unique solution for each individual patient. So the fit is extremely important, as John said, but the magic, the secret sauce, and many of the benefits come from respecting the anatomy, the shape of the anatomy, and I think that's really important to highlight, because it's conceptually very easy to grasp how optimizing the fit for a patient has a number of benefits, and those are all true, and we do benefit from those. But respecting the shape and the geometry of the anatomy is also extremely important.
So with shape matching and with matching a patient's normal anatomic shape, and obviously I have thoughts on this, but there's a little bit of a leading question here. What does that make better? Is it tolerated better by the patient's body because of the shape? Is it all ligament isometry and balance and how that knee moves and how that makes it feel? What's the prevailing theory of the advantage to that shape match?
Let me take that first, and then you can
Sure.
fill it in. Yeah, so the prevailing theory is that the shape, preserving the patient's natural geometry, preserves their natural soft tissue isometry. And so therefore, the surgeon does not need to modify their soft tissues in order to make a weird shape, which is the off-the-shelf knee, function, properly. And I use properly in quotes because what they need to do is modify the patient's ligaments in order to make the odd shape work correctly. Surgeons, for many, many years, have been argued that knee replacement surgery is a soft tissue procedure. It's not a carpentry procedure. And I say carpentry because you have to cut bone in order to install an orthopedic implant. And for an off-the-shelf knee, it is true that it is a soft tissue procedure because you have to modify the soft tissues in order to function properly with the non-anatomic shape of the implant. Put an anatomically shaped implant into a patient. You do not need to modify their soft tissues, their medial, lateral, posterior cruciate ligaments, in order for the shape to function properly. And therefore, what you get is a total knee that feels like the patient's original anatomic joint when they were younger. When you modify the soft tissues, you impart all kinds of new. I don't think I'd call them complications, but they're big compromises. You end up with patients that have the proprioception problem when they're walking down the stairs. Their knees sometimes feel unstable with an off-the-shelf knee, and that's because it's difficult to achieve perfect balance when you start cutting ligaments in the knee. If you don't have to cut them, and you only preserve the natural shape, and oh, by the way, the natural shape that we can do correction to for the disease, because deformity does take place in the hard tissue. And we have some secret algorithms that are based on sound science, peer-reviewed published literature that teach us how to recreate what the patient's natural shape is in the event that it's been diseased and changed its shape, and that all of that together preserves the patient's natural isometry, therefore a natural feeling knee.
So I want to unpack this a little bit for patients that might be listening or potential patients. I think surgeons and people in industry are picking up everything you're laying down. But when we talk about, as you said, knee replacement as a soft tissue operation, if this was just a matter of getting implants to cover the ends of the bone, putting metal and plastic where cartilage was worn away, and having it fit well and line up pretty straight, we would have had this knocked decades ago, and we would have nearly 100% satisfaction. I think, because surgeons are largely good at this and can do that reproducibly. But a gap here is, how do patients feel? What is their satisfaction? And when we talk about ligament isometry, we're just talking about balance, how the knee feels when it moves. Is it too tight in some positions and too loose in other positions? Does it feel weird? Does it hurt? Does it irritate the soft tissues? Those sorts of things. So I think you've spoken to that, and I hope that's a fair description of it. So maybe one or both of y'all, can we talk about patient satisfaction with knee replacement, and why custom? Why might we do this, and what is the evidence that it's better?
Why don't you start?
Sure. So, in order to create a solution, you need to have a problem, a well-defined problem. And in orthopedics and knee replacement surgery, it's widely accepted that about 20% of patients are not completely satisfied with their outcomes, the procedural outcomes. So that is the problem that we're trying to create a solution for. And conceptually, when you look at a knee is far from symmetric. When you look at the bony anatomy, there is a difference between your condyles, between the left side and right side of your femur. If you model the mechanics of the joint and imagine springs or rubber bands as the soft tissue that helps facilitate motion, kinematics, it's very easy to look at that asymmetric joint and then look at the implants that are currently used today, which are widely symmetric in nature, and say, well, that there's clearly a mismatch between the what is currently being used operatively and the normal anatomy. So what Conformis believes is that a substantial part of that dissatisfaction rate among patients can be attributed to the implant design. Certainly, there's a host of factors. There's all the clinical factors. There's certainly the patient and their commitment to rehabilitation and getting better. But a portion of that can be attributed to the implant, and that's where the idea of personalizing and making the implant match that patient. And what John said is so important about our algorithm, our proprietary algorithm for correcting deformity, correcting for wear, and the evolution of the pathology. So from that perspective, it's the problem was that there is a certain percentage of the population that is not entirely happy with the outcomes of their knee replacement surgery. And what can we do from an industry perspective in terms of the implant design to help improve that, to increase that satisfaction rate?
It's well said, Farzin.
Yeah, and I can certainly attest to that as we obviously have a lot and a very high percentage of great outcomes with knee replacement, but it's clinically not at the same level that we get with hip replacement, and that percentage of folks that aren't happy, even though, gosh, we think everything went really well. It's vexing to try to figure those out and what the solutions are and how we can make things better for those patients. Where are we at?
Hey, Matt, can I?
Oh, absolutely.
Can I offer up an analogy on the hip? So yes, patient satisfaction in hip replacement is extremely high, and it's very common for hip replacement patients to literally forget what side of their hip did they have, the left hip done or their right hip done. I actually this was about 10 years ago or so. A very famous leading orthopedic surgeon that I know had a hip replacement done, and it was now about a year post-op. And I said, "Larry, how's your hip doing?" And he said, "I had to stop and think for 2 seconds to remember, was it my left hip or was my right hip?" And this is an individual who was at the high end of orthopedic replacement and in hip surgery. So patients with hip replacements, they forget they have a hip. The reason, my hypothesis for that is this, that the human hip is a ball and socket. The orthopedic replacement for the human hip is a ball and socket, round on round. So the analog to the human hip is a nearly identical shape and size, where in the human knee, it's a highly unusual shape. And everybody's knee is very different. There are no two that are alike. So when you put a standardized off-the-shelf implant into a very irregular shape, you're changing all of the balances, you're changing just the way the thing moves. That's why, my hypothesis, that's why in the human knee, with an off-the-shelf knee, the satisfaction is much lower. If you look at in partial knee replacement, even off-the-shelf partial knee replacements have a much higher satisfaction rate than total knee replacements do. And the reason for that is, I believe, is because all of the soft tissues are preserved and rarely have to be manipulated in order to make a partial knee work properly. Take the patient-matched Conformis total knee, which has got the right shape for the patient, preserves their soft tissue isometry, it is more likely to feel like their preoperative or pre-disease knee.
I think that's a great way to put it, and I explain it similarly to patients. And I just, in my estimation, a ball and socket is a less complex joint. You've got this with a knee; it's a whole different thing with a multitude more ligamentous structures around it, different planes of motion. There's obviously flexion and extension, but there's some component of rotation, and that occurs at different points in that arc of motion. And it's just a lot more complex in its function, if you will, than that ball and socket joint. But I think your statement about what we're matching and what we're getting back to with the hip replacement is well put also.
With that said, I think it's worth to mention that we also have a hip replacement portfolio of products, and internally we characterize it as we developed a knee system for the patient because the joint is so much more complex. On the hip replacement side, we designed the system for the surgeon to make the procedure easier and more reproducible.
That's a great way to put it. When results are so good for hip replacement, you're certainly after efficiency and reproducibility and taking those outcomes and making them happen, every single time and getting us closer to 100% with things. What do you consider your best outcome studies at this point? What's the proof for the custom knee so far?
Well, you can look at patient outcomes and you can look at survivorship. I'm going to pick survivorship first. So there are two joint registries that are kind of reference points. One being the British Joint Registry, and we've been in that. Our total knee has been registered with that for now about 8 years or so. And what they do is this is a British federal government. It's federal government subsidized, but it's an independent group that basically follows from implantation patients with the total knee, or they follow all joints actually. And our 7-year survivorship for the iTotal in the British registry is 98.4%, I believe. And for the same time period, the average off-the-shelf implant is about 97.5%. So we're statistically and substantially better than the other implant systems that are out there. In the American Joint Registry, which is much newer, it's only been around for about 5 or 6 years, we've got similar survivorship. That is very, very high. It's in the 98+% of survivorship reported. We've got several published papers on patient outcomes that look at patient satisfaction, which I think is a very critical one. And these are now peer-reviewed papers, and they're comparative to, they're side-by-side with other off-the-shelf implants at the same time, or concurrently, I should say. And we're about 1/3 greater patient satisfaction on average in those studies compared to the off-the-shelf implants.
So most of these studies.
Thanks, Sean. I think.
Go ahead, Farzin.
Sorry, I also wanted to add in today's environment. I think you also have to talk about the economics of joint replacement surgery. And one of our most recent papers, an abstract that was presented at the Orthopedic Research Society just this year out of the University of Washington, and we weren't really even aware that this study was being performed, where they did a head-to-head comparison between Conformis and two other implant companies, two of the largest implant companies. And one was done by the one arm of the study was done by a single surgeon, and then there was a comparative done by a second surgeon. And what was really interesting is that Conformis performed economically when you added all the costs, the direct costs associated with the procedure, was about $1,000 cheaper from one implant and $1,300 cheaper than the other implant. And I think there's a lot of hidden costs associated in terms of the outcome, the rehabilitation, that simply respecting the anatomy adds all kinds of benefits in terms of outcome and recovery that directly lead to economic benefits. And I think in today's environment, you have to talk about the economics of the joint replacement as well as certainly the outcome.
Yep, agreed, Farzin.
In terms of a lot of your follow-up data, certainly the registry data is registry data, and I think that's pretty independent. Your patient satisfaction and outcome studies and some of the economics, are these studies still with folks that are designers or consultants to the company, or are you starting to get more independent review and get some eyeballs from folks that aren't involved with y'all commercially?
Oh, I would suggest that probably half of our outcome studies are done completely independent of Conformis, completely independent of any of the people that work directly with us. There's a paper out of Germany that compared patient satisfaction of the iTotal, and we had no idea that this was even going on, and compared it to patient satisfaction of one of the leading off-the-shelf total knee replacements. And the patient satisfaction for the Conformis total knee was dramatically increased over that of the competitive knee that it was compared to. So, I mean, fully half of the published literature outside of the joint registries are by researchers that are not involved with Conformis in any way.
That's excellent. And as we move to be more data driven, I think that's important for people because, you know, a lot of folks, I mean, obviously with commercial interest in these sorts of things can make claims, but data is data. And as we accumulate more of that, I think that contributes to what we all do and how we approach these things and how we think about what we're doing in knee replacement.
Agreed.
And having worked at a couple of different orthopedic companies over my 30-plus year career, I can tell you that there is a Conformis phenomena where surgeons that gravitate towards technology and start using the product, they become zealots. They really, initially they conceptually understand the engineering behind it, the great work that John and his team have done. And then they start to see the results in their patients, and they become, really passionate about the technology and the product, to the point where I would say almost all of our the surgeon designers and advisors had started out as users initially, and then we slowly brought them in as design surgeons, simply because they were so enamored and fascinated by the technology and saw the results in their patients.
So let me hit y'all with a clinical question that you may not feel compelled or qualified to answer. Is there who doesn't need a custom knee replacement? If they need a knee replacement, who needs something different and not this, or does that patient exist?
Oh, that's a hard question.
Hey, we're keeping it real here, John.
Yeah, I know. I know, right? Well, we actually don't know who will benefit and who would not benefit from a custom knee right now. We are entering into a research program that will probably take several years for us to determine what patients will benefit and what patients probably won't benefit so much or at all from the total knee. And so we honestly don't know which patients don't benefit. I think that we could say that which patients would benefit for sure is patients that might have a higher deformity at the bone surface interface. Certainly patients that have got, it's an relatively unusual condition, but the valgus knee, there's no doubt that the valgus patient would absolutely benefit from the iTotal. But when you get into the gray zone, we don't know the answer to that. We just do not know the answer.
So that is definitely a very strong engineering response. What I'd like to do is take it a little bit of a different angle and say, from the time we started, and I was with the company going back to the very beginning of the partial knee and total knee design back in 2008. And once you start taking the handcuffs off the design engineer and saying there is no limitations of what parameters you can change and how you can try to design the best possible implant you can. Once you start taking away those restrictions, then something really remarkable, something magical happens. So when we started designing the total knee system, we weren't just looking at matching the shape, and trying to get the best possible implant design. So that's all. When you think about it in terms of the implant itself, let's look at the femoral component. You're looking at the outer surface, where the shape matching happens, where you're respecting that patient's normal anatomy. Then you have the inner surface, right? The inner surface is where the bone cuts happen. But because we had no restrictions and the engineers were really allowed to design the best possible implant, we were able to minimize the bone resections on the implant, such that you're able to preserve as much of the native anatomy as possible. For example, most femoral components have 5 chamfer cuts. The Conformis knee has 6 chamfer cuts, and the reason for that is we looked at 5 cuts, 6 cuts, 7 cuts, and looked to see, how can we affect the implant strength while minimizing the amount of bone that's being taken away. So we were able to optimize that with 6 cuts and take significantly less bone away. So when you think about blood loss and what bone resection means to blood loss, and in covering the full anatomy with metal, and what that means in terms of blood loss, and then you take that to soft tissue releases, and when you respect the anatomy, how much less soft tissue releases you have to do. All those things compounded have benefits to patients from octogenarians down to your young athletic 50-year-olds that might 40-year-olds that might need a knee replacement. So I think every patient would benefit from a total knee replacement that's personalized for them. But certainly what John says is true. Certain patients will benefit more because of the shape of their anatomy. but looking at it holistically, I think every patient out there would benefit from a personalized toteming.
Yeah, you're right, Farzin. Guilty as charged. I'm the engineer.
No, I think you're both potentially right, and I think, as John said, it's something that can be studied, and if there's enough data points, you can kind of tease that out. And it's, not everybody needs to drive a Ferrari, right? So some patients that are lower demand may not get as much benefit, depending on their function, depending on what they were like preoperatively. It may not make as much difference as it might in another patient. But then to your point, Farzin, if there's less blood loss, if there's less bone loss, if they get their motion quicker and require less utilization of physical therapy resources and things like that, then there's some potential benefit there as well. So I can see that from both sides. And we'll give a little shout out to Will Kurtz there. I think he did that study about blood loss, swelling, and the fact that the system takes away less bone. And I think that is valuable, especially when you talk about a revision setting. Things will wear out. They will fail, even if you have, as you noted, John, a remarkably high survivorship. There will be some small percentage that will have to be revised, and
absolutely,
having available bone stock for that is better for the patient and just gives them more options long term.
Mm-hmm. Agreed.
All right, so we're switching gears here. You may be off the hook with this one, John, maybe not. This may be a Farzin question. And y'all have both used it here and opened the door for me. When we talk with patients about implants and they talk about sizes, things like that, I try to explain, with your system, this is a custom implant. With other conventional implants, those are made in a range of sizes. And so if you go way back to, PCA knee and some really old designs, there were small, medium, and large, right? I mean, it was very limited. Those have grown over the years. A lot of systems of conventional implants now may have 7, 8, 12, 15 different sizes of femurs. So it's not custom, but certainly there's a wide range of sizes available to fit patients. And as I think you've touched on, those don't necessarily match shape, but they're certainly better at matching size. But those conventional implants, somebody at Conformis somewhere at some point came up with the idea of labeling these as, quote, off-the-shelf implants, and that has got to be the greatest marketing coup of all time. Do either of you guys know the origin story of the quote-unquote off-the-shelf implant?
I don't. Farzin?
Well, there was certain language that we talked about and decided, going back to the one of our original vice presidents of marketing, John Lee. We discussed how do we want to characterize our implants, and how do we want to talk about off-the-shelf implants, generic implants, and there was some dialogue and some thought behind how do we accurately depict our implants versus implants that are not designed for each individual patient.
Well, I hope I'm not putting y'all on the spot too much with that one, but I find it pretty humorous because it sticks with patients. Patients that have seen any of your materials or looked this up, they I won't say they get the impression that other implant systems are just being pulled out of a junk drawer of whatever's laying around the hospital, but they definitely, that resonates with them, and they have strong thoughts about it. So I think that's an interesting concept that somebody on the marketing end really hit a home run with when they came up with that.
Well, we certainly want to be accurate in how we depict our implants and the implants of other companies. But we're very passionate about our technology and our approach. You could characterize Conformis as much as a software company as it is a joint replacement company. the power behind what we do is data and software. And if you look at the future of the company, in terms of next generation products, we're actively working on an implant system that's going to leverage all the historical knowledge, all those over 100,000 implants that have been designed specifically for each patient, to see if we can get a better off-the-shelf implant product that's limited in sizes, and if time is a factor, you can get it certainly a few weeks quicker. Still leverages the preoperative plan, personalized preoperative plan, and personalized jigs for placing that implant, but we match it using artificial intelligence and machine learning to the closest possible match to a personalized implant. And what's going to be unique about this product is that it's going to still respect the anatomy in terms of it's not going to be symmetrical, but you'll be able to get it sooner and still reap the most of the benefits from a personalized system. I think early on also it's worth noting we certainly had challenges, right? Being a small company in a industry that's dominated by 4 large players that have almost 90% of the market share. There was active dilution of our value proposition by other companies. They started to talk about personalized implants because of the jigs that they were producing. Whereas we were the only company that was creating a fully personalized implant, where the actual implants were made specifically for that patient. And I think that's a really important difference, that we wanted to make sure that we position ourselves in a way that people really understood, how we were different and what the value proposition was for our products. So a lot of the genesis of the off-the-shelf branding certainly dates back to that, so that there is no dilution of the value that we provide in the personalized implant with the jigs that some other companies also provide.
I think you've got a lot of great points wrapped up in there, and I think that's a neat idea with this potential forthcoming system, to have something that is CT based and that is matched to a patient, where you are using or sort of leveraging AI and some of these other technologies, and you've got this huge database of patient anatomy to know what's potentially best and what's right, even if it's not a fully custom system. And I think that also makes the point that this 3-dimensional planning that takes place with that, you've got 3D printed guides that are used during the surgery, and the accuracy associated with those, I think, is a story that gets lost on a lot of patients. I think for a lot of people, they sort of wrap their heads around the idea of this custom implant that's size and shape matched, but you're really bringing a lot of value with that single-use, sterile, disposable set of guides that are 3D printed for each patient.
Yeah, I completely agree. I think the hot story, the frontline headline news in orthopedics today seems to be dominated by navigation and robotics. We've always touted the fact that our jigs are incredibly accurate, and the same technology based off the CT imaging that goes into the software that operates the robot is the same exact information, radiographic information that we use to design our jigs to fit on the bone the same way. So we like to refer to it as pre-navigation. So the navigation and the benefits of robotics is encapsulated in our jigs, and that facilitate the placement of our personalized implants. And I think that's I appreciate you bringing that up, because I think that's a really important point to bring up in terms of the jigs and the value that they represent.
And let me add this, that so orthopedic robots have now been around for about 10 years, maybe a little longer. And so far, to my knowledge, there is not a peer-reviewed publication that shows a outcome benefit with a robotic installed knee compared to any other device, period. So it's a solution looking for a problem so far.
So, interestingly, I think that, or at least I'm given the impression that the ability to do this sort of mass customization technology has been largely facilitated by 3D printing, additives manufacturing. What's next? Does AI or machine learning or some of these other technologies get you to the point of being able to produce this from 2D imaging, maybe from X-rays instead of CT or some hybrid of something?
We will be investing heavily over the coming 2 years or so into artificial intelligence and looking at how we can exactly do that, improve the mass customization and reduce the overall cost of the system. So yes, the future is so bright. We need sunglasses in terms of the application of computer technology to our business. I can't imagine what it's going to look like in 5 years from now, but it's going to look very different.
Very well said, John. And I think the orthopedics industry, we need to think more software, more, how do we get leverage data to improve outcomes, whether it's through predictive analytics, artificial intelligence, machine learning. And those are areas where Conformis is absolutely investing heavily. When you think about and talk about 2D to 3D imaging, I'm personally have some healthy skepticism if we would ever have the technology refined to the point where we could design implants. But I do think that we can get it certainly to the point where we can create personalized some jigs and a preoperative plan, absolutely, and perhaps a way to be able to delineate and categorize or segregate patients that would benefit even more from a personalized implant, and then go down the CT pathway there. So these are, you're absolutely right. You hit the nail on the head. These are all areas that I think are going to be very hot topics in orthopedics in the next 5-10 years, and certainly areas where Conformis is investing heavily.
Awesome.
Additionally, there's a new technology that's emerging now where they're almost portable CT devices that can be literally installed in a doctor's office. So in the future, you won't need a big CT center. You won't need to send a patient to a CT center. You'll be able to do it in your own office and just send that CT scan to us. So that's going to be cost reducing and time reducing as well.
Gentlemen, you've talked about a bunch of stuff, and I think we've talked about the future. What else do we need to know? What is the future here? What's on your radar that you see that's exciting, that's coming down the pipe here for joint replacement?
That's another challenging question. I think you hit it, Matt. It's the application of AI. We will be looking into robotics, although there is some belief out there that with this move to the outpatient total knee, that robotics may have a limited life. Certainly, the large, expensive robots. Maybe there are some emerging smaller handheld robotic technologies that might have a place in the outpatient surgical center. We are looking at that. We'll be at least investigating that over the next 12 months or so and seeing how that would apply to us. But we do see if the total knees in a large way shift to the outpatient setting, the life expectancy of at least the large expensive robots, I think, is very limited. And that's going to need to evolve as well.
Farzin, any thoughts?
What's that, John? No, I think John encapsulated that extremely well. We are going to continue to look to see what areas have the greatest need and the greatest opportunity for technological improvement. And Conformis has always taken pride in its kind of out of the box thinking, its approach to orthopedics and joint replacements. As a company that looks for unique ways to add value. We've never been one that felt we needed to market our products to in order to get traction. We believe our technology speaks for itself. And we're going to continue to look for ways to leverage our core identity of data and software to see how we can add value and help patients recover more quickly and have better outcomes and hopefully improve their quality of life. It's all about patients and surgeons.
Gentlemen, thank you all so much for joining us. Conformis is an exciting idea and exciting technology. It's been helpful, useful, and exciting in my practice over the last couple of years on a personal level. And I thank you all for coming on and sharing with our audience a little bit about that.
Thank you very much, Matt. Have a great day.
Thank you very much. It's been a pleasure and an honor. Thank you.